we're going to be doing practicing mu substitution for week 3, number 21. So either of you can just say your name.
And my name is Gage DeBell. Yep.
Okay, I'm Matthew Knott.
Okay. All right, let's go. Let's start with number 1.
Okay.
So find the indefinite integral. Oh.
I don't even.
Because we're all pros at this, right?
Yeah.
Yeah.
I'm definitely not.
Oh, come on. So are we gonna do a U substitution here? Do we like?
So I think your U is because you have the cubed in there. That would be your U because you have to take that step out.
Yes. So U will be equal to 5x squared plus 1, right?
Yes.
Yeah. And then we have the integral saying the integral sign and then a U to the 3rd power. (10x dx). So
Yeah, this week's been a lot harder than last week was.
yeah,
So what are both of you guys' majors?
I'm a biology.
I'm mechanical engineering.
Okay, I'm electrical engineer. Oh yeah, computer engineering. Sorry.
Computer.
Cool.
All right, let's see.
So we'll add one to the power correct. So that would be it would be U to the 4th, and then you have to divide by 4. I don't really understand what you have to do with the 10x dx.
Yeah, let's see. I'm actually gonna go ahead. We can use we're just practicing, so we can use tools, right?
Yes.
Yeah.
I'm gonna go ahead and look at rule from alpha. And see what it says. Okay. All right. Are you both sitting in Rexburg?
Yeah.
Nice.
Where are you at?
In Sweden.
Oh.
Long ways away.
Yeah.
What time is it there?
It's 5:16.
In the morning or afternoon?
Yeah.
Oh, okay.
You know, I think we should look backwards a little bit. Look at the key and see how it worked
Yeah, work
out.
backwards. Yeah.
And just see the patterns so that we know how to work. Because if we don't, yeah, we're not learning.
All day.
So So the u equals the 5x plus 1. Have you guys pulled it up?
I'm pulling up right now.
Okay.
Okay.
Yes, I have it.
And the du. Oh, okay. So you know how it says to take the derivative of u? At the inside. That's what the 10x is.
Oh, okay.
First, like du over dx.
Oh.
And then they move over 10x to the dx, 10x dx, so that du equals that.
Yeah, okay.
And then you can take the integration of uq du, and then you get the u4 and that plus c, and then we substitute it back. Okay. Right. Now I see what's going on. You guys got that, or
Yes.
No.
no?
Yeah, I'm a little lost on this, but hold on, I'm doing some reading. See if it will jump back.
What's your question?
I guess I don't understand. Like the and this is something I was having problems with the reading last night as well. Is the I don't understand why U4 goes over 4.
Okay, so that's the backwards power rule.
Okay, like the whatever was it?
Antiderivative. Yeah.
Antiderivative. Thank you. Okay. Okay, I can see that. Okay. Yeah, I think I understand it.
All right, just
Okay.
stop if
Okay.
it doesn't make sense. So number 2. What's our u there first?
Let's say x cubed plus 1,
Mm-hmm.
just because that's the most complex one there. Yeah, and that's what the teacher did too. Awesome.
So
So then we'll take the derivative of that, correct?
right.
X cubed plus 1 for our du.
Yes. So du over dx equals 3x squared. But what about that x squared outside, though?
Can't we move that to the other side and mix it with the dx? Or not mix it, that's not the right word. Because the x squared, we'll say root u, multiplied by root u is the same as root u multiplied by x squared.
Wait, say that again?
So wouldn't x squared root u be the same as root u x squared? Where we just reverse the 2 that we're multiplying?
Wait, say that. So wouldn't x squared root u be what?
So we have x squared root u dx. If we ignore dx, it wouldn't matter where x squared is, either before or after root u, correct?
Yeah, you can move that around.
Yeah.
Just around the same thing, because it's still following the chain of command. That's not the right word either. Chain of operations.
Yeah.
that should be okay to put on the other side, and couldn't we mix that with the dx to make the du?
Wait, I'm kind of confused. Sorry, it's
It's
just a
all
lot
right.
going on at the same time.
It's okay. It's okay. All right. So just reverse what side x squared is on of the root.
So
Okay.
you want to put it next to dx?
Yeah.
Okay, so you're saying that we're having, because we're getting du over dx equals 3x squared, right? Like when we take the derivative of the inside function.
Oh, wait. Say that one more time. Sorry.
When we take the derivative of the inside function.
Sorry. Which part are you saying we're? Start at the beginning of that. Sorry.
So we have the u, right? And in order to get du over dx, like that's the derivative, right? So like we did on the other side, on the first one, 10x, right? That was du over dx.
Yes.
So we do that the same way here, right?
Okay, I'm gonna check over what the teacher did. Hold on.
Okay.
Yeah, so we're on the right path. Or maybe we're not. No. Hold
Yeah,
on.
so it says du equals 3x squared dx.
Yeah.
That's just a more simplified.
Oh, okay. Okay.
It just moved over dx to the other side.
Okay, that makes sense then.
But it used to be du over dx.
Gotcha.
Oh, okay. If you look at the next thing there, we have the x squared there, right?
Yeah.
Do you see how it's du over 3, right?
Yeah.
Uh-huh.
So
Oh.
we divide the 3 there, so we get du over 3 equals x squared dx. And then, I guess, does that like cancel out the other one or something? Or oh, okay. I see what's happening. So it's like the other side, 10x. We need to match it. Basically, we need to get it to be x squared like it is there. Do you guys see what's happening?
I'm lost at this point, I guess. Not lost. I'm not completely lost.
Not
I think I get it.
kind of, but not really.
I'm gonna try to explain it. So you see how we have x squared there, right?
Uh-huh.
It's like you said before, we can move it around. It can be anywhere. So that's the same as the 10x.
Yeah.
Yes.
The only thing is that the derivative of the inside becomes 3x squared, okay?
Yes.
And we want it to be x squared, because that's what we have on the outside.
Oh.
So when we divide it by 3, we get x squared.
X squared.
Yeah, and when we have a division like du over 3, we can pull out 1/3 in front of the integral sign.
Uh-huh.
Okay.
And then, because that's a constant or something like that, so we pull that one out, and then we take the integration of u at that point. So then we have the integration of u to the power of a half, and then x squared dx.
Okay, I can see that. Yeah.
So that, okay. Yeah, I get that. I get up to there.
Okay, and then let's see. Well, x squared dx, that is equal to du over 3, right?
Correct.
So we write 1/3 integration sign u to the power and a half, u to the half power, and then we write du. And then we take the integration of u, which becomes, let's see,
u over something.
U, yeah. So it's going to
1/2.
be 3 through the power of 3 over 2.
Yeah, so you add 1 to the power, and then you divide by that number.
So it's going to be 2/3.
Okay, that makes sense.
And then we have 1/3 in front of that. That's going to multiply by that. And we got to add the c as well. You guys on board?
I think so.
Yes, I get it now. So I guess it's the last step from the 1/3 to the answer. I guess the last line on what she has on the answer.
Yeah, so like what the 1/3 comes from?
Yeah. No, I get where the 1/3 comes from.
Okay.
So the 2/9.
The 3/2 in the denominator.
Okay, so it's the backwards power rule, right?
Yes.
So you add 1 to the power, so that's 3/2. And then you have n plus 1. So you have half plus 1.
Okay.
So that's why you divide by 3 over 2.
Yeah. Okay.
And in order, and like if you want to bring that up and take away the fraction, you just flip them.
Okay. Yeah, I get it now.
Okay.
Hey, so I have this sheet from the math lab, has all of the what are they called? Sorry, derivatives and integers. Do you guys want me to email you a copy of it?
Sure. Show me that again.
Yeah, I've seen that one. I'd like one. That would be great.
Yeah, I would love that.
I'll scan it and send it to you guys right now. Hold on.
Okay, cool.
But yeah, it's been super useful for all of these.
Okay. Do you want me to wait for you before we start the next one?
No, let's just keep going. I'll have to send it to you guys afterwards. The batteries are dead in my scanner.
Okay. All right, so for next one, the u is going to be x squared minus 1, right?
Yes, that's what I would say.
Yeah, I think so too. Now, can the u ever represent the square root as well? Could we replace square root x squared minus 1 with a u?
Yeah, you can put anything into a u.
Okay. Okay.
Yeah. So the u is basically just substituting something, and then we just plug it back once we're done. Oh yeah, we forgot to do that.
Plug everything back.
Number 2.
Yeah.
So plug back the x, so 2 over 9, and then we have the x cubed plus 1, 3 squared, 3 over 2, plus c. Okay. For the next one, we had x over u dx. So what I like to do in this situation is to separate them. So that would be like kind of like x times 1 over u.
Oh, okay.
And then we can write u as a negative 1 power. And then dx. And then we got to take the derivative of the inside, so we get 2x, right?
Yes.
2x, and then we get du equals 2x dx.
Uh-huh.
And we want it to be x, so we divide by 2, so we get du over 2 equals x dx. And that's what we have. So then we take out the 2, so we set like a half in front of the integral sign.
Okay.
And then we have u to the negative 1 power x dx. And now we apply the power rule, or a backwards power rule. Wait.
So because it's a square root, won't it be? Will it be a negative 1/2?
Yeah. Well.
Is it?
Yes. Yes, you're right. Thank you for that. Well.
Because it's. I guess it's because it's in the denominator. Is that why it makes it a negative?
Right. Thank you for that.
Oh, because we need to invert it. Yeah. Okay.
That's good, because otherwise it wouldn't have worked anyway. It's a negative 1. Because then we would have to divide by a 0. Okay. Next step, we apply the... Okay, so are you guys both with me?
Yeah.
Yep, good.
Okay. Then we do... Let's see. +1, so it's going to be 1. So it's going to be 2 in front of the u, right?
Well, we have the negative. So we have
Negative
1/2 integral u to the negative 1/2.
Right.
And then so we add 1 to the power and then divide by that. So it'll be, we'll have u to the 1/2 over 1/2.
Yeah. So that's 2u a half.
Yes.
And then we multiply that also by a half.
The 1/2. So then that cancels, so it goes to 1.
That's basically square root of u.
Yes.
And then we can just substitute it in.
Squared minus 1. Let's see.
Cool. So I
That
got...
was a little easier.
Yeah. Well, I think we're starting to understand it now.
Yeah.
I got square root of x squared plus 1 plus c.
Yes, that's what I got.
I got 2.
Does anyone else want to, like...
All right, so we'll jump into 4. Is that what we're doing?
Sure. Go ahead.
Okay. So 9 minus x squared is u, I would assume. Can we put a parentheses inside of du, like the negative 2x?
So it doesn't matter just because it'll just be that negative 2x dx,
Yeah.
which will equal your du.
Yeah. Okay.
And then
So we have u to the 1/2.
Uh-huh.
U will have du.
What'd you say?
Oh, sorry, u to the 1/2 du.
Yep.
Okay, so then let me see if I remember how to do this. Add 1 to the power and divide it by that.
Yes.
So it would be u divided by 3/2.
And the u is to the 3/2 power as well.
Oh, okay.
So.
And this is where I hit a wall. Terrible with fractions.
And so you just substitute the u back in, and then simplify it.
Okay, so 9x 9 subtracted by x squared.
Did you get it?
Yeah, I think I'm missing something.
Where at?
So I'm looking at the answer key versus mine, and I'm not on there. I have 9 minus x parentheses 9 minus x squared, and all that to the 3/2 power over 3/2 plus c. But
is that what you have?
What?
Is that what you have?
That's what I had. The answer key says 2 outside of parentheses of 9 minus x squared to the 3/2 all over 3 plus c.
Right. So what did you have again?
9 minus x squared to the power of 3/2 all divided by 3/2 plus c.
Yeah, that's the same thing. It's just simplified a little bit.
Is it? Oh, okay.
So what did you do? Go ahead.
They just multiplied by the reciprocal.
Oh, okay.
They brought the 2 up.
That makes sense.
Cool.
Okay.
Equals my u. Okay, so we good to go on number 5?
Yeah.
Yeah.
Okay. So your u will equal 4x squared plus 3.
Okay.
And then it'll be x dx. Your du will be x dx, correct?
Right. I didn't see the x there. I'm glad you pointed that out.
Yeah. What I do is I usually take the derivative of the inside first, and then see what I get for my du.
Oh, I guess we do have to take the derivative of u.
Yeah,
Okay.
so then I get like 8x dx. And since that is x dx, I just divide it by 8.
Okay.
But I mean, there's several ways to go ahead and do this, I think. So
Yeah. And so then we take the integral of 8. Yeah, I guess I'm kind of lost there on what to do next.
So like you have 1 over 8 outside of the integral sign, right?
Okay, yeah.
And then you have u to the 5th du.
Yes.
Then
And
you
then-
just take the integral of u to the 5th.
Okay, then we just put that back in.
Yeah. So then we get
1/8 integral of 4x squared plus 3 to the 6th divided by 6 plus c. And then so you take the.
Okay.
Okay, then you just take the 6 multiplied by the 1/8.
Yeah.
Okay.
So you get like 4x squared plus 3 to the 6th power divided by 48
Divided by 48.
plus c.
Yes.
So wait, where are you guys getting the 48 from?
So you have the 1/8 times the divided by 6.
Yeah. Okay, I see it.
Cool.
You can do it either way. I think it could be, you could take it to the, let me see what that would be. To the 3, you could put the 3/4 out in front of the parentheses, or you could just divide by 48. If you know what I mean, if you just multiply 6 by 6 over 1 times 1/8 would be 6/8
Mm-hmm.
to leave that in front of the parentheses, or just divide everything by 48.
Wait, what did you say to put the what?
So if you, like on the last step, how we
Uh-huh.
brought the 3/2 up instead of put it in the denominator.
Where are the 3/2?
No, sorry, in question number 4.
Oh, yeah,
How
yeah, yeah.
the last
Oh,
step
yeah.
we divided by 3/2.
Uh-huh.
This was just opposite of what we did on the last one.
Okay.
So we brought the number that was in front of the parentheses down to the denominator instead of the number from the denominator up.
Yeah. Did you get 4 divided by 48?
Yes.
Okay, good.
Yeah, I did too. So is that the final answer then?
Yeah.
Yes,
If you
it
have
is.
substituted out the u, yes.
Okay. Yeah, that's everything. Cool.
Cool. All right, let's go ahead.
All right.
So one.
Oh, good. Sorry.
Oh, okay, I'll go ahead. So u equals 1 plus x to the 4th. Forward. In this one, let's divide them up as well. Like, so we have first rewrite it a little bit. X cubed divided by u squared dx. Let's write it as the integral sign x cubed times 1 over u squared dx, which is also the same as x cubed u to the negative 2 dx. Okay? You with me?
Yes.
Yeah.
I'm okay.
All right. Now we take the derivative of the inside. So du over dx equals 4x3, and du equals 4x3 dx.
Yes.
And then we say du divided by 4 equals x cubed dx. So we set 1/4 outside of the integral sign, and then we have u to the negative 2 du. We're there?
Yeah, I'm good to there.
Yeah.
Okay. Let's integrate. So we get u to the negative 1 power and over negative 1, right?
Yes, it'll be over -1.
Okay. So that is the same thing as u to the negative 1 divided by negative 4. And that is the same as 1 over negative 4 u, right?
Yeah.
So yeah, you bring that power down, yeah.
Mm-hmm. And then we plug it back in, plus c, I guess. So then we get 1 over, or we can just set the negative sign in front of the whole thing. So 1/4 1 plus x to the 4th plus c. Yep. Looks good.
I'm good to there.
Yeah.
Yeah.
Sweet.
Brought down the squared, but that I don't think I'm supposed to do that. I'm not supposed to do that. So I'd accidentally brought down the square with the u. So I put 1 plus 4 to the 4th, and all of that squared. But
Yeah.
I didn't. I'm not supposed to do that.
Good catch.
Okay. All right. This next one, I'm gonna assume 1 plus 1 over t is u.
Mm-hmm.
And then 1 over t squared dt. Okay, so I'm jumping back and forth between this and the answer key, and I guess I don't understand this. It's saying that it's negative 1 over t squared dt is negative du. No, I don't see where the negative comes from.
So if you take the derivative.
Oh, that's right, derivative. Sorry.
Yeah. So you have the t to the negative 1.
Yeah, that. Okay, now I see it.
Mm-hmm.
Okay, which makes it negative. Okay. Then we have u to the 3 negative du. Okay, so then we would be.
We're gonna have to set a negative 1 in front of the integral sign, right?
Yeah, you'll have the negative.
Okay. So then it's u to the 4th divided by 4. I guess
Yeah,
we
plus
can
your
move the
c.
negative 1 over. We can move the negative 1 over now, right? So it's just negative u to the 4th over the 4th plus c. That's
Wait.
not the answer, is it?
I'm not there yet.
Okay, sorry.
So I've just pulled the negative 1 outside of the integral sign.
Okay.
Did you start integrating already?
Not yet.
Okay.
In fact, I got caught up in the negative 1 and assumed it was done, and I'm not.
So what I have now is negative 1 integral sign u to the cube du. Is that what you guys have too?
I have negative du.
I don't think you can have negative du. You want to have just a du to integrate it.
Okay.
I think that's why you divide by negative 1 to pull it outside of the integral sign.
So that's what I did as well. I pulled the negative outside the integral sign.
That makes sense.
But it's the same because when you integrate, the negative has to come back as well.
Right, that's true.
So, okay. Okay, well then we do the negative u to the fourth divided by 4 plus c, and then it's time to put all of our figures back in.
Yeah.
So we get 1 plus 1 over t to the fourth divided by 4 plus c. Do you guys ever feel like you're overthinking something and it's clearly done, but you're like, I think I'm missing something?
Yeah, that's what I'm doing on this one. I was like, I've got to do something with the 4 in the denominator. It's not right there.
I don't think we do. I think the 4 can stay, can't it?
It stays there. Yeah.
I mean, if you
So,
want to, you could. Yeah, I'll just leave it there.
yeah.
Okay.
So I got negative and then a parentheses 1 plus 1 over t, all that over 4 plus c.
Yes, that's
Yep,
what I got.
that's what I got.
I mean, you can substitute the negative 1 if you want, but.
No, that makes sense.
Oh yeah, and we gotta have that to the 4th power. Forgot that. And that's not the 4 on the bottom. Okay, yeah.
Yeah.
Good
So,
job.
number 8.
Yep.
So, would your u be t minus 2 over t?
Yep.
Sorry, making a lot of noise.
You're good. And so, your du will be
T squared du. And then, hold on.
That one's a little more complicated, but.
yeah.
Hey, guys, I just looked at the answer to check on where we move next. It says no inside function. Don't use u substitution.
Wait, what?
So check the answer to for 8. It says there is no inside function, so we don't use u substitution.
Oh, really?
I just pulled that up too.
Oh, what?
I guess I don't know what that.
Oh,
I don't know.
oh, we just substituted. Okay, yeah. Well, this one's simple.
So you just multiply it out.
Yeah.
So it'll be t to the third minus 2t dt, and then you just integrate that, which would be t to the 4th over 4 minus t. Oh, sorry, minus 2t to the 2nd over 2. And then you just simplify that. So that goes to...
Plus c.
Oh, yeah, plus c, sorry.
I think that's it.
Yeah. Well, that one was nice.
Yep.
So the solution says that that's not the end. It says
Wait,
it's
what?
2 to the 4th over 4 minus 2t plus c is the final answer.
Yeah, he
So-
has just taken the 2 divided by 2 and put a 1 there.
So that just simplifies to 1. To the negative 1t squared.
Yeah.
Gotcha. Okay.
Am I out?
I think so. Yeah.
So u is x squared plus 2x minus 3 then.
Mm-hmm.
In this one, yeah, so let's say x over 1, x plus 1 divided by u squared. We're going to have to break them apart again. So x plus 1 times 1 over u squared dx, which is equal to x plus 1 times u to the minus 2 dx. Now we take the derivative. Du over dx equals 2x plus 2. So du equals 2x plus 2 dx. If we divide by 2, we get x plus 1, so du over 2 equals x plus 1 dx. So we pull a half outside of the... Are you guys with me?
Yeah, I'm good so far.
Okay, a half outside of the integral sign, and have u to the negative 2 du. We integrate, we get a half times u to the negative 3 over, what was it, negative 1, right? No,
So
sorry.
you'll add 1, so it'll go to negative 1.
Yeah.
So it'll be u to the negative 1 over negative 1.
Yeah.
Yeah, that's what I have.
So that means that is equal to 1 over 2u. So this is all negative, though. So negative 1 over 2u.
Yes.
And now we substitute plus c. So we substitute that in. Okay. You guys got it?
Yeah, I'm good. So I got negative 1 over 2 parentheses x squared plus 2x minus 3.
Yep.
And then plus c.
Plus c. Cool.
Yep. I ran out of room.
Yeah, we don't have very much space.
So I'm like writing it in a different place and drawing lines. I'm like, yes, this one goes here. Okay. So number 10. Okay, so I don't see a function in here. So is this just another algebra one?
I think. Yeah, because there's nothing.
Yeah, you can do the algebra here. So that would just take like t plus 2t squared, set that in a parentheses, and multiply it by t to the half power. So we get like t to the 3 halves plus 2 to the 5 divided by 2.
So,
Okay.
what I did is I just split it up. So I put t over root t plus 2t over root t, or I guess you could do t to the 1/2. I guess we're going in the same direction either way.
Uh-huh. Oh. Okay.
So.
Oh yeah, it's 1/2. Sorry.
Oh, it's okay.
There. And 3 halves. Yeah. Yep. You're right. Thank you. Go ahead.
Okay, so then we have to add 1 to the power and drop it down.
Yes.
Okay. I think this is where I'm stumped.
And we also divide by 3 over 2.
Yeah. So then we would have, what is it, 2 to the 2/3 over, or say t to the 2/3 over 3 halves?
Yeah.
Is that right?
Yep.
I'm not confident with that answer.
Oh, it is.
Okay, so we have 3 halves, so we add 1 to that would be 5 halves, so 2t to the 5 halves.
Yep.
Over 5 halves.
Yep.
Plus, I guess we'd put c there now, right?
Yes.
Yeah.
Okay, then bring 2 up on both of them, so we have 2t to the 2/3 over 3 plus 5. No, hold on. Okay. I don't know why I wrote 5 there. That's t. So then 2t to the 5 halves over 2 over 5 plus c?
Yes.
Is that what you guys got?
That is what I got.
What is 4 over 5? T. What did you say?
So I got 2t to the 2/3 all over 3.
Yep.
Plus 2t to the 5 halves all over 5 plus c.
I got 4t to the 5 halves over 5.
4t, okay. Because we need to multiply 2 by that, right?
Yeah, I've probably done that wrong, though.
I'm really not confident with my answer here, so I'm not sure.
So we had 2t over 5. How did you get to 2?
Say that again?
So I just pulled up that answer to see.
Yeah, I see that too. But I have like the 2t to the power of 5 halves.
I think it should be 4 as well, because that 2 just kind of, that 5 the 2 under the 5 just kind of disappears.
That's true. That's what I'm thinking too.
Yeah, I think you guys are right.
Maybe we'll email her and tell her.
Yeah, there has been a few errors in the keys before.
Yeah.
Problem was in the equation right before it, I forgot to write the 2 in front of the t, so I had it as 1. So 1 times 2 would make it 2.
No.
But I forgot to put the 2 there. That's my fault.
Okay.
I'm seeing the error here. So I think you're right. I think it is 4t over 5.
All right. So for next page, I guess it's just checking the answers like.
True or false?
Yeah. And it's the
Okay.
same equations. So the first one there is false.
So it's false because it's not the same thing that we ended up with.
Yeah. So that's basically what we gotta check.
Oh, all right.
Next one is actually true. I think no,
No, I think that X one's false.
no,
isn't
the
it?
x to the cubed is not gonna be there.
Yeah, because yeah.
So false. Next one.
So I think that's false too because we ended up with just the square root of u squared minus 1 plus c.
Wait, what did you say? We ended up with what? X
You-
squared. The square root
Oh, yeah,
of x
x
squared
squared.
minus 1, right?
Yeah,
Right.
that's not what that simplifies to.
Nope. No. Yeah, so false.
4. Yeah, they're missing the 2 at the top of it. Wait, hold on, but it's divided by 3/2, so that would work. But
It's still an x
that-
too much.
yeah, that's still false because the negative 2x squared over 2.
Yeah, that's what messes it up.
Yeah. 5.
False.
Yeah, so we ended up with what was in the middle. Almost.
hmm
If all of these are false, I'm gonna shake my fist in anger. Um,
What did we get?
that one would have to be false.
That's what I would say as well.
Yeah, that doesn't. 4 more. She better not.
So that one's false as well because the negative 1 over t.
Oh, yeah.
Yeah,
Yep.
we can't have the t there. Three more.
Okay, T3.
Yeah, false as well, right?
2 more.
False.
Yeah.
Yeah, that's false.
10. That's false, isn't it?
Yes.
Ah. All right. Well, that was fun. I feel like I actually understand this now.
Yeah, a little bit better.
That
So-
clarifies yesterday's prepares things that I was having questions on as well. So I know I'm gonna go back and do those now.
Yeah, that was
But-
the same problem I was having yesterday.
How much time do you guys usually put into this class every day?
Between 2
4.5
and
to
3
5 hours.
Yeah, that's
Or 2 to 3.
I'm
Huh?
up to a lot of time. Like,
How much
Really
do you guys put in? You said
I've put it up to like 5 hours, usually 4.
I don't know, like 3. I usually get away with 2 or 3, I guess.
Okay.
Yeah,
But
this week's been a lot harder for me as well as of last week.
Yeah, I've taken calculus before though,
Okay.
Oh, okay.
so it's a lot of review.
Yeah.
I took the business calculus, like 119, and I realized I can't take multivariable or what's the other one? Differential equations. With that class, I have to go back and take this one. So it's essentially the same class, except without the trigonometry or something.
Yeah. Huh.
So, yeah. But it's fun. I don't mind it.
So I don't know if you guys would want to do this, or this is something I've been doing for a few years. I've got a time clock app on my phone, like what you'd punch in for work, and I have one for each of my classes, so I punch in to see how much time each class takes.
Yeah.
It's been really useful because I can go back and I can see like where the changes are, and I can see like my grades to see if it reflects how much time I'm putting in.
Wow, that's cool.
That's cool.
By the way, I'm just gonna stop the recording now.
Okay.